Right, so let's start with what's animation. Alright, let's start with that. Yeah, good. Okay, everybody good? By the way, in the class, you should take notes all the time. You know that, old students, but the new ones, take notes. The class is not the slides. The class is the videos we share on Slack, the conversations we have. It's not just the slides, okay? Just because it's not in the slides, it doesn't mean it will not be in the exam or it's not important, especially in this class, which is about animation. And the slides are not very good for that. Make sense? Good. So I'm going to start with what is animation? Can anybody tell me what's animation? Yes.
Characters created characters that
Yeah, go on. Beshahir. What is it? Anybody else? Yes. You. Your name? Rim? Aliazia. Pictures that can move? Pictures that can move? A picture with legs. Is that what you mean? What? Anybody else? Yes. Name? Shema. 3D characters is animation?
No, it doesn't have to be 3D. It doesn't have to be.
Yes.
It's a sequence of pictures.
Sequence of pictures. Yes. What's your name again? Bonus point for Raya for today. Animation is a sequence of something, hopefully pictures, so I can put this properly. Yeah. Rapid display of sequence of images to create the illusion. Illusion. What's an illusion? Name.
It's like delusion.
Illusion.
It's like delusion, like from outside. Right?
What is an illusion?
Visual pictures. False.
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 Illusion is false.
Like false vision.
A false vision is an illusion. Interesting. And everybody agrees with that? A false vision. I like that. Okay. Something that you think it's real, but it's not real. Okay? For example, when you watch a movie, you think these big things are moving, right? Inside the screen. But actually it's just a sequence of images that change, and if you look very slow, it's like this, right? But in your head, you think it's like this, but in reality, it's like that. Make sense? That's an illusion, something that is not real. Okay. So how quickly we should display the images so the brain, we can fool the brain? How quickly? 1 image per second? 2, 3, very fast, 10,000. How fast? How fast? What's the minimum amount of speed that we should do? 16. Very good. 16 times per second. Okay? 16 times per second. If you think something will not 16 times per second, any brain will think it's moving smoothly, but in reality it's not. Make sense? Yes. So that's the minimum, but you know, when you do that, your brain starts, you can see flickering sometimes, it's not very nice. So when they start developing this stuff, especially TV, they said 24 or 30. Make sense? So in Europe and here we use 24 for the TV. It's called the PAL system. In America they use NXTC, NSTC, and it's 30. It's a bit faster. But then they have less pixels on the TV. Got it? So Americans see faster TV and you guys see slower TV but bigger. What do you prefer? Doesn't matter. Nobody watches TV anymore. Do you watch TV? No.
Yes.
Who watches TV? 1, 2, who? And sometimes. And who doesn't watch TV at all? Who didn't watch TV yesterday? You didn't watch TV. You don't have TV in the dorms. That's okay, fine. What about the weekend? Do you watch TV on the weekend? YouTube? Do you watch YouTube? Yes. Yes. Great. Okay, is it clear what's animation? So we said there's a thing called frames. A frame is a photo of a drawing in a paper. Well, that's for the Disney movies, okay? You got it? You make a drawing, you take a picture, make another drawing. Yeah? It's pretty boring. Takes a lot of time. Do you know how much time does it take to make a movie? Like Pixar, Disney, one of those. Who says 1 year? Okay, 10 years. Who says 10 years? 5 years.
Maybe 3 years.
Who says 3 years? Who says 2.5 years? 3 years. In general, it takes 3 years. That's the movie, eh? The idea to have the movie can take 5 years, 10 years. That's the traditional way to make movies, okay? Traditional animation definition. Okay. There are 4 ways to make animation. These are the 4 ways. Keyframing, data-driven, procedural, and simulation. So let's start with the first one. I can explain later. See? No. Keyframing. Keyframing is this thing. You draw everything by hand, you take pictures. Okay? And there's the senior animator, and he will draw the movie every 1 second, more or less, or between the most important steps. And then those are called the keyframes. And then the younger animators, like you would fill with, between those keyframes, you would fill with other frames. Does that make sense? And that's called keyframing. There's the experienced animators, they draw the most important frames, and then the people that need less skill, they can fill, cheaper people, they can fill in between. Got it? That's one way. Second way, data-driven. Have you seen these people that put these balls on their head and they have a... You saw it? Do you want to watch a video about it? Somebody who wants to watch a video? No? You want to watch the video? Okay, look at the other screen. Is this video? Yeah, here. Difference with. Sorry, motion capture. Sorry. Okay, so here you have some crazy people.
So everyone helps.
So this is a motion capture frame suit, and let's see the output. Can we see it? No, we cannot see it. Let me show you a better one. Oh, here. Actually, no. This one is very good. Oh, here. You see the guy? Oh, disgusting. Let's see. What? Disgusting. Here. Oh, wow. Motion capture. Okay. I think now there's an AI that you don't even need the dots on your face. You just will do it like that. On Facebook chat, right? You have that. Have you seen it? Okay. So it's improving a lot. Also, I'm a dinosaur. Okay. Yeah. So they can even make you look younger, or if you're pregnant, that you're not pregnant in the movie, or lots of stuff. So that's called motion capture anyway. It's kind of, it saves a lot of money, right? Because to animate by hand all that stuff, it's expensive. So that's data driven. You have a lot of data and you transform it into something nice. You map it into something procedural. What's that? Procedural. No? Okay, so let's see. Animation block. No, school of fish. Fish. This is pretty good, and this one is pretty good also. All right, so here somebody made some fish. And they look like fish, isn't it? Kind of. They behave like fish, yeah? So, whoa. Okay, so, and also for, let's see, for, no. Okay, no. So if you analyze how birds and fish and horses and sheep, they behave, the behavior is very simple. For example, for fish is they don't want to be alone. So if I'm alone, I go to the biggest group of fish I see near me. And if I'm inside the group, I swim with the group. If I'm on the head of the group, they follow me. Right? It's very simple rules that depend on distance. Very simple. You can program those rules to every fish. And then The fish just became that fish. Isn't it awesome? Awesome. Unless you want to program every fish, and if there's 1,000 fish, you want to do it? No. So that's another technique they use in movies to animate. The last one is simulation law of physics. So Fortnite. Who's playing Fortnite? Can you bring the game next time in your laptop to the class? Oh, okay, got it. And on iPhone, I have it in my iPhone. It's pretty good. So anyway, that game has a physics engine. Every game has a physics engine where the gravity is programmed. So if you make a game, you don't need to program the gravity and all the physics laws like wind resistance and water resistance and all that stuff, and floating on the water, all that. Some geeks program it. It's called a physics library, and the good libraries and all the games use the same library or main libraries. Okay, all the games use the same, more or less. Once I met a guy who was working for Sega, and his job was to program the Sega physics library. That was his job, his only job. Can you believe it? You know that thing you learn F equal mg? MA, yeah, MA, yeah. But programming the game, so you can focus on the game and don't worry about lots of physics later. Yeah? And that's simulation. Do you want to watch a simulation? Where would you apply simulation in an animation, for example? Where do you think it's the best scenario or objects to apply simulation? To save time. What? What's that? Can you repeat? Fighting scenes. No. Where would you apply simulation? Would you apply simulation to a conversation? No. What? Yes.
The pilots and the first officer, they have some courses and they have to go to college and simulate. They have the simulator.
Okay, that's called a flight simulator.
Yes. There's a car simulator.
There's a car simulator, but those are like software to learn something, and that's more a game. We call it simulator, but it's more a game. But in computer graphics, when we simulate something, it's usually for waves of the sea. There are many waves, right? You don't want to program. You don't care exactly how the wave goes, so you just make a program, say, hey, wave, do this. Shut up, do this for 10 minutes. That's it. So you call it a loop or something, and you made it. That makes sense? Got it? So here's some typical example of waves. Let's watch this one. He's gonna make a wave. See? Now he made a wave. Really good. Here. Okay, so that's done with Maya. That's another software. It's an expensive one. So it's Maya. That's one place where you would use. Here's another guy who made a simulation. Water, bubbles, all that stuff is perfect for simulations. Sky, clouds. Did you play Unity engine here? Unity games? Unity engine, do you know it? No? Unity.
I know the yeah.
So Unity, the wind in the game is simulated. It's pretty good. Trees. leaves of the trees moving with the wind. You don't want to program every leaf, right? So that's perfect for simulation.
Does the crash involve kind of simulation?
The car crash.
Yeah.
Yeah, that's another very good point. So wanted to touch on that. So car computer crash simulation. Excellent point. Another interesting area of computer graphics is simulation of car accidents or engineering simulation. Is when you simulate the structure, for example, if a bridge will hold, all that stuff. In those softwares, visualizing is very important because you maybe have the whole car built with CAD, and then you want to simulate if it will stand a load or a lot of stress or something. So those are called engineering simulations, and they use finite element method or algorithms to test before building the car if it will hold the normal things that the car has to do. Example, bridge. What fit should it be? I don't know. You build a model, you make a simulation, you put the load in the middle and see what happens. Does that make sense? In those examples, simulation is important, and in what you say, car crash, it's very, very important. So let's see if we can find a good one. Car crash simulation, cat. Yeah, perfect. Let's see. So engineering. Perfect. Wow, pretty awesome. Here. So when companies build cars, they have to pass a test of crash. One of the crash is side impact, front side impact, where they hit a column or something on one side only. And when they design the car, they need to make sure that when you crash, the motor is in the middle and it will come inside the passenger, and usually it will cut the passenger's leg because the motor block is there. It will come inside. That's a problem. It's called intrusion. So what the car manufacturers do is that they design the car that when there's a crash, the motor will move downwards, not inside where the passenger is. The way the motor is put together with the chassis of the car, it's designed that it will go down when there's a perspective.
It sense.
Yeah. This started in the 90s. So that's very, very good. But it's very expensive to do that. Like you have to build the iron and all the stuff, and throw the car fast. It's expensive. You cannot go very fast. You have to build it, throw it, check what happened. But here you can do it very fast and very cheap. So in 2002, for example, Honda, it will take for a computer 3 days to do this simulation. And it will take 1 day for the engineers to build a car and get a car and test it. It was faster to smash the car than to do the simulation, but now it's much faster to do the simulation. So this is another very interesting area of computer graphics. It's very important to visualize how it deforms. Let's see. Here you have another one. So this is all very realistic, and they have achieved a lot of level of realism. And here you can see, oh, we should put more reinforcement here, or more iron here, or whatever. They have to make sense. Okay, so shall we? Awesome. Okay. And all that is done with a technique called finite element method. So what they do is they slice the component in very small triangles called a mesh. And that mimics what happens in reality. All right, awesome, very good. Yeah. Okay, anyway, simulations. So which one do you think of these four methods is the most popular today? What? Cannot hear you. Really? Simulation? Okay, let's go. Pixar. How do they do the movie? They use keyframe, really? By hand. That's why Disney movies are so good. Okay, interesting. Okay, so in the next days we will see what they use, okay? But it's they use a mix of these four. In Japan, for example, they still very traditional because the Japanese didn't learn to use computer graphics very well, so they refuse to learn new technology. So if you're following anime from Japan, there is this hit now. It's called Miracle Ladybug. This guy, I don't know. I've been told it's like super. Have you seen this? Do you like it? How is this done? So this anime is very interesting because it was the idea of a French guy. And he went to the Japanese studios and said, I have this idea of this story. Why don't we make a series about it? And the Japanese studios said, yeah, we don't think so. And okay, maybe. And the guy said, okay, I want to do it 3D, like this. And the Japanese studios said, no, we want to do it by hand in 2D. And then, no, we're in 2018. I want to do it in 3D, computer graphics. So they didn't agree. So then the guy went to Korea. The Koreans are a bit more, they jumped the ski. And they went direct to computers. They're very good at computer graphics. And they did it in Korea. Now it became a success, and the Japanese were very upset about it. They disagreed. All right, cool. So that's it for today. The next day, I'll see the homework. Questions? Lady with a Slack problem, can you come? You fixed it. Okay. Any questions? If you need to contact me, the best way is Slack. The second best way is, and the last way is a phone call. All right? Great. Phone call. Yeah.